Welcome learners to my kcse revision channel, Teacher James Marita, Rewards Boys High School. Kindly subscribe, click the notification bell such that you get notified once I upload a new video. You can also follow me in our Facebook page, James Marita, the Ocean of Chemistry. Follow me on TikTok, James Marita, the Ocean of Chemistry. Today, we are looking at kcse revision in mathematics, trigonometry part 4. So we have find the values of theta. Find the values of theta, and the theta lies between the range of 0 degrees and 360. That satisfies the equation. Our equation is it is sine 2 theta, which is equals to negative 0.5. So to solve this for theta, to solve this one for theta, we have this one is sine 2 theta, which is equals to negative 0.5. What you normally do here, you just find the sine inverse in both sides. So if this is the cos, you just find the cos inverse in both sides. If this one is the tangent, you find the tan in both sides. So in this case, we have sine 2 theta, which is equals to negative 0.5. So you find the sine inverse in both sides, such that we eliminate this sine. So from finding the sine inverse in both sides, we remain here with 2 theta, which is equivalent to the sine inverse of 0.5. Just leave a negative first, deal with the 0.5. So the sine inverse of 0.5. So this one you can just find the sine inverse of, in this case, 0.5. And the sine inverse of 0.5 is giving us 30 degrees. So our 30 degrees in this case, this is our principal. We call this one as our principal angle. So the first step, check. If we have, this is the sine, make sure you find the sine inverse in both sides. If this one here is the tangent, you find the tan inverse in both sides. If it is the cosine, make sure you find the cos inverse in both sides. Now, I have left this negative. The negative here now, you should use it on the unit circle. So the next step from here, draw the unit circle. Make sure you use a unit circle. The unit circle is where we can get our correct solution of theta. So in this case here, what we have in our unit circle. So if we can have this our unit circle here, then we have our unit circle. So we have this unit circle like this. That is our unit circle. So if this is our unit circle, in the first quadrant, all of the trigonometry are positive. In the second, only the sine, which is positive. On the third, we have the tangent, and then we have the cosine, which is positive. Now, in this unit circle, we need to get where the sign is negative. The sign is negative in which quadrant? Is it on the first, the second, or the third? So from here, we have this negative, and we need to have a negative sign on this quadrant. So here, it is all of them, they are positive. Here we have the sign is positive. So we have the sign is negative here, and the sign is negative there. So we find this one on the first, we find on the third. We are getting this one on the third quadrant. So our solutions lies on the third quadrant and on the fourth quadrant. This is where we have our solutions. So we have our solutions on the third quadrant and the fourth quadrant. Now, so in the first quadrant, we have only theta. So we can represent this one by theta. In the second quadrant here, it is 180. So we have 180 in this case minus theta. Minus theta. So in the third quadrant, we have 180 in this case plus theta. So at this point here, you will have plus theta. And on the fourth quadrant, we have 360 in this case minus theta. So understand this one very well. First quadrant we have theta, that angle, which is the principal angle of course. Kama tungekuwa tumeipata at the first quadrant, hapo ingekuwa 230 degrees, but now it is not there. In the second quadrant, we have 180 minus theta, minus the principal angle. The third quadrant, we have 180 plus theta, and then the last, which is the fourth quadrant, we have 360, in this case minus theta. So where is our this principal angle? So we find it's on the third quadrant. So we have as 2 theta. We write this one as 2 theta is equivalent to, in the third quadrant, we have 180 plus theta. Our theta in this case is equivalent to P 30. So 180 plus 30, we have this one as 210. On the fourth quadrant, we have 360 minus theta. So this is 360 minus 30. This one is giving us 300. We have this one 330 degrees. Now, we have the range here is between 0 degrees, that is our theta. Then we have 360. But in this case, what we have here, we have 2 theta. So we can have 0 degrees. Then we have this is 2 theta. Then we have this is 360. When theta is 0, so we take 2 times 0, which is giving us 0 degrees. When theta is 360, we take 2 times theta. 2 times 360, we have this one as 700. So we have this one as 720. So our range now will change. From 0 to 360 to 0 degrees to 720. So make sure you understand this one very well. If you cannot understand this one here, you will not get the correct solution. So now, it means now we are moving the second. Again, as such that we have up our range to 720. So we have this is 210, then we have this is 360, then we move next. So we take this 210 plus 360 because we are moving another complete. So we have another complete circle such that we have up to 720. So we have 210 plus a complete circle of 360. So that one is giving us 500. So we have this one as 570. We are not in the range of 720. So we move next now. If we move next, we come here to 330 plus 360. So this one is giving us 690. So these are now the possible solutions we can have from this unit circle. So we have 210, we have 330, 700, 570, 690. Make sure you use this concept very well and you understand very well. If you cannot understand this part, then you will not get the correct solution. Then from here we have that our 2 theta is equals to 210, 230, 330, 570, 690. So if we divide by 2 in both sides, so our theta is equivalent to B. 210 divided by 2, we have this as 105 degrees. And then this 330 divided by 2, we have this one as 165 degrees. Then this one is giving us 285 degrees, and this one is giving us 345 degrees. All of these ones here are the possible solutions of theta because our range was between 0 degrees and 360. But because of these 2 theta here, the range now will change. It will change, and the period will just change from between 0 degrees to 720. Meaning now we have to move and the second complete circles we can have. So these are all the possible solutions of theta. We have that solving for theta we have 2 sine 2 theta minus 15, then plus is equals to p cos 3 theta. So if we have sine theta here, if we have that this is sine theta will be equivalent to p cos alpha. So what you need to understand here is that theta in this case plus alpha is equivalent to p 90 degrees. This is what you are supposed to use here. So wherever you see a sine is equals to cos, sine is equals to cos, it means that sine plus cos is equals to p 90 degrees. Therefore, from here, our 2 theta, so we have 2 theta minus 15, then plus 3 theta, this one here, this is equivalent to p 90. A very important thing you need to understand. Wherever you see sine is equal to the cos. So theta plus the sine plus the cos, sine theta plus cos theta is equal to p. Sine theta plus cos alpha is equal to p 90 degrees. So make sure you use this relationship. That is when you will get these questions correct. So we collect the right terms together. 2 theta plus 3 theta. We have this one as 5 theta minus now 15, and this one equivalent to p. We have that one as equivalent to 90. So we have, this is our 5 theta, which is equals to p. Here we have 90, and therefore we are transferring this 15 from this side to this side. This is a negative here. When it closes the equal signs on the other side, it will change the sign. So we have this one as a positive. We got that one as positive 15. So we have, this is our 5 theta, which will be equivalent to the 105. To get theta, you can divide here by 5, you divide this one by 5, and our theta is equivalent to p. Our theta is just equivalent to p 21 degrees. This is the solution for that. So the one thing you need to understand, that wherever there is a sine and the cos, so you talk of sine theta plus cos alpha is equivalent to p 90, or just you say theta plus alpha is equivalent to 90. Given that sine 3 sine into theta plus 30 degrees is equals to p cos 2 theta. Find the values of cos theta plus 40. So it is the same thing that we have done here. Where there is the sine and the cos, it means that theta plus alpha is equivalent to 90. So it means that here, that our theta plus, in this case 30 degrees, plus 2 theta, this one here, is equivalent to p. So we have that one as equivalent to 90. So we take theta plus 30 plus 20, because this is the sine and this is the cos. That one will give us 90. So 2 theta plus theta. So we have this one as 3 theta, then plus we have this as 30. This one will be equivalent to p 90. So we have, this is our 3 theta, which is equivalent to p. We have this one is 90, and therefore we are transferring this 30, this is a positive. When it closes to equal signs, it becomes a negative. So we subtract 30. So we have, this is our 3 theta, which will be equivalent to 60. You divide by 3, and this one you divide by 3. So our theta in this case is equivalent to p. Our theta is equivalent to 20 degrees. So if we have our theta is equivalent to 20 degrees, we were supposed to find cos. So we have to find cos theta plus 40. Therefore, we say that this one here, cos theta, in this case plus 40, this one will be equivalent to, we have, this is cos into, our theta here in this case is 20, so we have, it is 20 plus 40, we have this one equivalent to p cos 60 and cos 60 is equivalent, cos 60 is equivalent to 0.5. Cos 60 is equivalent to 0.5. The last part, determine the amplitude, the period, and the phase angle. Where we have of the wave, our wave is y is equals to p for our wave y is equals to p for sine x plus 40. So this wave is arranged in a such way that y is equivalent to it is in this case a sine into bracket. So we have p x in this case plus c. So then from here you get the amplitude. The amplitude is equivalent to, amplitude is normally equivalent to A. It is just A. You pick the value which is before the sine, the value which is before the cos or the tangent, and that one becomes our amplitude. So what is here in this case, from this equation here, our amplitude is equivalent to 4. The period of the wave, so we have the period of the wave. Period of the wave normally is equivalent to P. The coefficient of x, you check the coefficient of x, then you take 360, you divide by the coefficient of x. So in that case here, the coefficient of x here is P. So it is just 360, you divide by P, which will be equivalent to, this is 360, then our coefficient there is 2, and this one is giving us 280. Then you talk of the phase angle. So we have, this is a phase angle. Phase angle, sometimes we can call it the shift angle. So we call it the shift angle. That one will be equivalent to that constant C. And the constant C is equivalent to what? The constant C is equivalent to 40. This is the easiest questions that somebody is not supposed to miss. So amplitude, you just talk of here, in this case, which is equivalent to 4. The period, you take 360, you divide it by the coefficient of x. The coefficient of x here is 2, and that one will give us 180. The phase angle or the shift angle is just that constant C, which is equivalent to 40 degrees. To pass mathematics, you have to do a lot of practice. You kindly follow my channel, click the notification bell such that you get notified once I upload a new video. Thank you for watching.